Today I'm going to talk about fermentation and the reduction of an aldehyde into an alcohol, specifically ethanal into ethanol, in the fermentation of beer. As you may already know, fermentation is the metabolic process where yeast, or in some cases bacteria, convert sugars into ethanol and carbon dioxide. I'm a visual learner, so as you can see here, we start with one molecule of glucose that came from the grains in the brewing process, such as barley. It gets converted by the yeast into two molecules of ethanol, the stuff that makes you feel good, and two molecules of carbon dioxide, the stuff that fizzes on your tongue and helps release the flavors of the beer. That's not the whole story, however. As we can see here, glucose is first broken down into two pyruvate molecules. The two pyruvate molecules are then broken down into two acetaldehyde molecules, or actually they're called ethanal molecules, and that's where we get our carbon dioxide molecules in the process as waste products. We're going to focus on step 3 of this reaction, where acetaldehyde or ethanal is reduced to form ethanol, more commonly called alcohol. Here's a little demonstration of actual fermentation happening. This is a Tank 7 clone with some Bell's Saison yeast going to town here, creating a lot of carbon dioxide and ethanol. Remember, in the middle of that step there's actually ethanal, and as you can see here, the airlock is bubbling away. So I've given you a brief and simplified overview of the fermentation process, and what we're going to look at now is the last step of the process, where yeast and sometimes bacteria convert the acetaldehyde into ethanol. Alright, I'm going to start off by drawing our aldehyde here, which in our case is acetaldehyde. So we start with two carbon atoms. We have a double bond to an oxygen atom up here. We have 3 hydrogens off the left carbon, and one more hydrogen right here. Okay, so what makes this an aldehyde, off to the left here, this is our organic group, and right here, this carbon double bonded to this oxygen atom, that's our carbonyl group. So this is acetaldehyde, and what yeasts are going to be doing when they're fermenting is reducing this molecule, acetaldehyde, into ethanol. And the way they do that is they start with a coenzyme called NADH, and the enzyme inside yeast is called alcohol dehydrogenase. It first starts by taking this hydrogen off of NADH, and that oxidizes NADH into NAD+, which gets recycled and used in the first steps of the fermentation process. So we take that hydrogen atom and we bond it down here. Now I'm going to simplify this. This molecule is now in an unstable state, and we need one more hydrogen to complete this reaction. So we're going to assume inside of our cell we have an excess of water, which is H2O, and we're going to take this hydrogen right here, and it's going to react with this unstable molecule. Again, I'm not drawing the intermediate steps that make it unstable, but we take this bond that was right here and we flip it up, and we put that second hydrogen right here. So what alcohol dehydrogenase has done here is it has reduced acetaldehyde into ethanol. This is our alcohol group up here, and NADH was the reducing agent. It has now been oxidized to NAD+, and we got a second hydrogen from water, and we're left with a primary alcohol, which is ethanol. So what does all this science and chemistry add up to? Well, hopefully a tasty beer to put in your mouth.